Hello again. We are looking at problem 16 in section 3.1, and the equation is linear in x and homogeneous, and we're supposed to check whether x1 cosine 2t and x2 cosine squared minus 1/2 are solutions to this equation, and then we want to check whether linear combinations of these two solutions will provide all solutions. And so first let's check whether they're solutions. If I take the derivative of x1, the derivative of cosine is minus sine, and the derivative of 2t with respect to t is 2. Differentiating again, the derivative of sine is cosine, and again another factor of 2 comes out. This is minus 4 cosine t, and cosine 2t minus 4 cosine 2t plus 4 cosine 2t is 0, so that's a solution. Let's check the other one. The derivative of cosine squared is 2 cosine times the derivative of the inside, which is minus sine. And then think of this as minus 2 multiplying cosine times sine. The derivative of cosine times sine is cosine times the derivative of sine, which is cosine, so I get a cosine squared. And the derivative of cosine, which is sine, times the derivative of cosine, which is minus sine, times sine, which gives me minus sine squared. And so I have minus 2 cosine squared minus sine squared. I'd like to relate this back to cosine squared, and so I remember that 1 is cosine squared plus sine squared, so if I subtract 1, that's subtracting sine squared, which is what we want, but it also subtracts another cosine squared, so I need to add another cosine squared. So again, 2 cosine squared minus cosine squared minus sine squared gives 1 cosine squared minus sine squared. And so let's see, what do I have? I have minus 2 times 2 is minus 4 cosine squared plus 4 cosine squared, so that's 0. And I have minus 2 times minus 1, which is plus 2, and then plus 4 times minus 1/2, which is minus 2. So I have plus 2, minus 2, and that's also 0. So x2 is also a solution to this equation. Now we need to decide whether any linear combination of x1 and x2 will give us all solutions. We're still in problem 16 in section 3.1. We're trying to decide whether the solutions x1 and x2 are linearly independent. And the way we're deciding that is we're taking the determinant of the matrix that has x1, x1 prime, and x2, x2 prime as its column vectors. If these solutions are linearly independent, then they will span all initial conditions and therefore give us all solutions. So here we go. x1 was cosine 2t. x2 prime was minus 2 cosine t sine t. And then x1 prime was minus 2 sine 2t. So when we subtract, we get plus. And then this was x2. So let's see what we've got. Cosine 2t is cosine squared t minus sine squared t. And sine 2t is 2 cosine t sine t. That's true for any t, and so we can write everything in terms of just plain sines and cosines and see whether that's 0 or not. Okay, let's see. What do we have? One of the terms we have is cosine squared times cosine times sine, meaning cosine cubed times sine. So we have minus 2 of those here, and then over here we have 2 times 2 is 4 times cosine t times sine t times cosine squared. So that again gives me a cosine cubed times sine, and there are 4 of them, so 4 minus 2, I have 2 left. Let's see what we have left here. We have minus 2 times minus 1, which is 2, sine squared times sine, which is sine cubed times cosine. So we have 2 sine cubed times cosine. And then down here We already dealt with the cosine cubed. What's left is this minus a half times 2, which is minus, and then 2 cosine t sine t. So that's what we have left. So let's think about this now. We have cosine t sine t multiplying minus 2. And here we have cosine t sine t multiplying 2 cosine squared. And here we have cosine t sine t multiplying 2 sine squared. So we have 2 cosine squared plus 2 sine squared. That gives us 2 minus 2, which gives us 0, multiplying cosine t sine t throughout. And so 0 times cosine t sine t is 0. So we decide that this Wronskian is 0, and therefore that the solutions x1 and x2 are not linearly independent in the space of the initial conditions. So we cannot match all initial conditions with x1 and x2, and therefore this is not a fundamental system for the solution.